Good evening. Welcome back, and we'll have one more session of calculus in which I'll be covering a very important topic, differentiation or derivative. So I'll be covering the topic under following heads: concept of differentiation, rules of differentiation, derivative of some standard function, differentiation of composite function or chain rule, differentiation of implicit functions, some important substitution during differentiation. So let's get to the concept of derivative or differentiation. So the question is, what is differentiation? So differentiation is nothing but like we studied in limits or on a curve. You have to find limit at a particular point and find whether the point is continuous or not. You can find it by coming from the left hand side and the right hand side. And after finding that the point is continuous, then you can say that the point will be differentiable. Not all the continuous functions are differentiable, but most of them are. The concept of derivative. Derivative is nothing but if y is equal to f of x. X is an independent variable, y is a dependent variable. So dy by dx is the derivative. The rate of change of dependent variable with respect to independent variable is the derivative. Okay. Now let us see graphically what is differentiation. So now this is a function. Now let us have this point as x, some distance from x, x plus h, and the dependent variable f of x plus h. Okay. So, like in the earlier topic, I've told you about limits. Here also we'll use the concept of limits. But in this graph, this is x o x dash y o y dash. Okay. So now let us find the slope of this at point x. Let us name these points P and Q. So let us find the slope of the line. So slope, as we know, is y2 minus y1 upon x2 minus x1. So here we can replace y2 is f of x plus h, y1 is f of x, x2 is x plus h, x1 is x. Okay, so let us replace this. This is f of x plus h minus f of x upon x plus h minus x. So this would be f of x plus x minus f of x the whole upon h. So this is the slope. So now when we take limits, because h, the distance here, this distance h is if it is very small, that it is tending to 0, limit of h tending to 0. It is very small. So this will come to this point and we will get a slope at this point P. So slope it will be tangent at point P. So if limit of h tending to 0 means h is infinitesimally small, very very small. So what you get, the derivative is nothing but the slope of the point, slope of the curve at that particular point. Okay, so this is also known as dy by dx. This is called the first principle of derivative. Now graphically I've told you. Now let us see what is physical connotation of derivative. So what I told you, it is a rate of change of dependent variable with respect to independent variable. So let us have this graph in which time and distance graph. S is the distance. Okay. So time is the independent variable and distance is the dependent variable. So if we take here a curve like this, or it can be like this, whatever way you can do. So df upon dt is the derivative. Like this is dt, so small, this is t, small change in t, small change in f, which is the distance with respect to t. So what is call the small change in difference with respect to time? It's called velocity. Okay, or speed. If it is a vector quantity, it will be called velocity. So as the distance is changing with respect to time, so rate of change of distance. So that is the physical connotation of differentiation. Okay, we can call it as V. Now we understood the concept of derivative, its geometrical form, its physical form, and now let us see some of the rules of derivative. Rules of differentiation. So d by dx of constant k is 0. Derivative of constant multiplied by function is the constant multiplied by the derivative of the function. D by dx of two functions f of x and g of x is derivative of f of x plus derivative of g of x. Derivative of k f of x, k1 f of x plus k2 g of x will be taken as 1 d by dx of f of x plus k2 d by dx of g of x. Now coming to the mostly used but important as per your ND examination and your 12th examination. Evaluate the product of two functions f of x and g of x will be equal to g of x d by dx of f of x plus f of x d by dx of g of x. As you can see, differentiation of ratio of two functions d by dx of f of x upon g of x would be g of x d by dx of f of x minus f of x d by dx of g of x the whole upon g of x. Okay. Now let us see differentiation of some of the standard functions. D by dx of x raised to n is n x n minus 1. D by dx of log x to the base e is 1 upon x. So, gentlemen, it's very important. E, the natural log or ln, a differential of natural log is 1 upon x. Differential of log of x when the log is not natural or log is to the base a. It is 1 upon x log a. D by dx of a raised to x is nothing but a raised to x log of a. D by dx of e raised to x is e raised to x. D by dx of sine of x or derivative of sine of x is cos of x and derivative of cos of x is minus sine of x. Derivative of tan of x is sec squared of x. Derivative of sec of x is sec of x tan of x. Derivative of cosec of x is minus cosec x cot x. Derivative of cot x is minus cosec squared x. Derivative of sine inverse of x is 1 upon root of 1 minus x square. Derivative of cos inverse of x is minus 1 upon root of 1 minus x square. Derivative of tan inverse of x is 1 upon 1 plus x square. Derivative of sec inverse of x is 1 upon x into root of x squared minus 1. Gentlemen, this x is always positive. Okay. Similarly, derivative of cosec inverse of should be the sign would be negative minus 1 upon absolute value of x root of or mod of x root of x squared minus 1. Derivative of cos inverse of x is minus 1 upon 1 plus x squared. Now, I'll tell you, there is a pattern to it, and you can understand that wherever a differentiation of c, cos, cosec is there, the sign here cos inverse of x, the sign is minus. Cosec inverse of x, the sign is minus. Also, cos inverse, cos of x. Derivative of cos of x is minus sin of x. Okay. So, derivative, wherever there is c, the result would be negative. Just keep this thing in mind. Okay. Now, let us take an example. Y is equal to x raised to 1 by 3 plus x raised to 1 by 2. We have to find the derivative and is equal to 81. So, let's do it. Okay, so we got the derivative 1 upon 3 x raised to minus 2 by 3 plus 1 upon 2 x raised to minus 1 by 2. Now we have to take the derivative at x is equal to 51. So 1 upon 3 x raised to, or we can say 81 raised to minus 2 by 3 plus 1 upon 2, 81 raised to minus 1 by 2. So, gentlemen, 81 can be written as 3 raised to 4 and 1 by 3 is 3 raised to minus 1. Okay, this will be minus 2 by 3 plus 1 upon 2, 9 raised to 2 is 81 minus 1 by 2. So this will come to 3 raised to minus 1 into 3 raised to minus 8 by 3 plus 1 by 2 raised to minus 1. So here, using the property of indices, 3 raised to minus 8 by 3 minus 1 plus 1 upon 2 into 9. 9 raised to minus 1, 1 upon 9. So this would be 3 raised to minus 11 by 3 plus 1 upon 18. So this is your answer. Okay. So got the derivative, then apply that very point. What is the value of that slope? So you got the answer. Let us take one more example. Y is equal to e raised to x plus e raised to minus x upon e raised to x minus e raised to minus of x. Or simplify to a form in which you can apply the derivative easily. This can be simplified the right hand side. E raised to x plus e raised 1 upon e raised to x upon e raised to x minus 1 upon e raised to x. This will be e raised to 2x plus 1 upon e raised to x upon e raised to 2x minus 1 the whole upon e raised to x. This would be, so y becomes right hand side. This is nothing but e raised to 2x plus 1 upon e raised to 2x minus 1. Okay, so y is equal to e raised to 2x plus 1 upon e raised to 2x minus 1. So now you simplified it. Now we can see this is in the form of uv, u by v. So let us take the derivative. So dy by dx would be equal to e raised to 2x minus 1 d by dx of e raised to 2x plus 1 minus e raised to 2x plus 1 d by dx of e raised to 2x minus 1. The whole upon e raised to 2x minus 1 the whole square. Okay. Now simplify it. E raised to 2x minus 1 d by dx of e raised to 2x is 5 raised to 2x plus 0. So this will be minus 2 minus of e raised to 2x plus 1. Now d by dx of e raised to 2x minus 1 d by dx of e raised to 2x is 2 e raised to 2x plus 0. So the whole upon e raised to 2x minus 1 the whole square. So this would be e raised to 4x minus 2 e raised to 2x minus 2 e raised to 4x minus 2 e raised to 2x. The whole upon e raised to 2x minus 1 the whole square. Now e raised to 4x, this will get cancelled. So this will become minus 4 e raised to 2x the whole upon e raised to 2x minus 1 the whole square. This is your answer. Depending on what options are given, you can change the answer. Okay. So e raised to 2x you can take in the denominator and it will become, if you take inside the bracket, it will become e raised to 2x minus 1 upon e raised to x because of this square. So if you want to further simplify it, it would become minus 4 upon e raised to 2x minus 1 upon e raised to x the whole square because this square here, and this can further be simplified as minus 4 upon e raised to x minus e raised to minus x. So depending on whatever options you have given, you can further simplify it. Differentiation of a composite function, where there is function where we say fog or gop of g of x or g of f of x. If two functions are there and one function is the function of other functions. Okay. For example, f of x is equal to log of x, g of x is equal to cos of x. So f of g of x, or we can say fog of x. What is fog of x? At x is equal to 0. So let us find out. So f of g of x would be log of cos of x. So where there is x, you put the other function. Log of x, in place of x, you put g of x, which is cos of x. Now let's differentiate it. D upon dx of log of x is equal to d by dx of log of cos of x. So d by dx of log x is 1 upon x and cos of x is minus sin x. So this will be 1 upon cos of x d by dx of cos of x. So this would be cos of x minus sin of x upon cos of x. This would be equal to minus tan of x. Now we have to find at x is equal to 0. So this is dy by d upon dx of fog of x. Now d by dx of fog of x equal to minus tan of 0, which will be equal to 0 again. So this is how you solve or differentiate composite functions. Differentiation of implicit functions. Implicit functions are functions in which x and y both variables are there together. So it is in the form of f of xy is equal to 0, or it is an equation which consists of both the variables x and y. So let us see how to do it. So this is your function. This is in the form of f of xy equal to 0. So d upon dx, let's differentiate both sides. X squared plus 2xy plus y cube is equal to d by dx of 42. So we know right hand side would be 0 because differential of a constant is 0. So d by dx of this is 2x plus 2y plus x dy by dx plus 3y squared dy by dx is equal to 0. Here I have used UV formula. Okay, 2 is outside because it is constant. Y d by dx of x, d by dx of x is 1, so y into 1 is y. And second x dy by dx. And then the third term, y cube. So dy by dx of y cube we will use n minus 1, so 3y, 3 minus 1 is 3y squared, and then dy by dx will come. Okay. So, and right hand side dy by dx of constant 42 is 0. Now let us take the dy by dx term to one side. So this will be 2x plus 2y plus 2x dy by dx plus 3y squared dy by dx is equal to 0. Now let's take all dy by dx as common. So one side 2x plus 3y squared, and let's take this to the right hand side is equal to minus 2x plus minus 2y. Okay, now what we can take is dy by dx would be equal to, put it in the denominator, minus 2 if taken x plus y the whole upon 2x plus 3y squared. So this is how you do the implicit functions differentiation. Okay, now let us see some of the important substitutions. Gentlemen, before differentiating the equation, if you find that you can substitute the function and make it in the simpler form, please do it. That will make your life very easy, and that will simplify it and save your time. Okay, some of the important substitutions are when the function involves the term a squared minus x squared, you can take x is equal to a sin theta or a cos theta. Why? Because here x squared, a squared, sin squared theta, a squared common, 1 minus sin squared theta would be cos squared theta. Generally it is under root, and then you can remove the root by the square. So if it is a squared plus x squared, x is equal to a tan theta or a cot theta. The same logic. A squared tan squared theta. So a squared common 1 plus tan squared theta, sec squared theta, and then the root will go. So this is how you can very well simplify it. Root of a plus x upon a minus x or a minus x upon a plus x, x is equal to a cos 2 theta. 1 minus cos 2 theta is 2 sin squared theta. 1 plus cos 2 theta is 2 cos squared theta. Okay, so you take this and then you can simplify the terms and make it easier. So if the function involves a squared plus x squared upon a squared minus x squared or a squared minus x squared upon a squared plus x squared, the same thing. You take, there we have taken a cos theta, cos 2 theta, here you take a squared cos 2 theta. Okay, similarly if it is 2x upon 1 plus x squared or 2x upon 1 minus x squared, just take it as x is equal to tan theta. Okay, then this will get simplified. And very important, sin x plus b cos x. So you can take a is equal to r cos alpha and b is equal to r sin alpha to get it in the form of sin of alpha plus x. Okay, so this becomes in that form. Okay, so that's it for the first part of differentiation. I'll get the second part of differentiation very soon. See you then.